So let's go ahead and start taking this thing apart. And so the first thing we need to do to take this apart is grab the casing and the top, and we're going to twist and unscrew the top off the casing. It's very simple, and it twists right off. Then we're going to pull this piece out. And you'll see that this piece is actually all the rest of the pieces. There's nothing left in the casing once you pull it out. Okay, what else do we got in here? Well, if you look, there is our gasket that we saw earlier that we discussed in our last video. And if we pull it down, it's attached to some spring which pushes back up. And oops, let's pick that back up here. You can kind of see how the system works. As the tube gets pushed up, the spring pushes back down. And so, what happens? Well, water comes in through the bottom of this and builds up pressure through the tube until it gets to the top, until it gets to this cap here. And when the pressure gets high enough, the cap gets pushed up. And now that the cap is pushed up, water can stream out the side of this cap through this tiny, tiny little crack here. And once water pressure stops, the cap and the tube are able to drop back down into the rubber gasket, sealing it. And what's pushing it back down? Well, clearly the spring. And so to take the rest of this apart, at least most of it apart, we're going to pull this piece down. And then I'm going to grab not the very top, but the second part, the yellow part for mine. Yours might be black or blue. But I'm going to twist this piece off. Next, you'll see that there is a filter inside this little piece here. Hopefully you can imagine what that filter does. It's just a little plastic piece. And then you'll notice that the gasket actually detaches from the spring, which makes sense. This is rubber and this spring is metal. They shouldn't be made out of the same material. Okay, and what else do we got on here? Well, on the bottom of this tube, there's this little plastic piece, this little white plastic piece, which if you look, is used to catch the spring. You can imagine what would happen if this fencing was not here to catch the spring. Well, what would happen would be the spring would sometimes pop through. I'm sorry, that was off camera. But the spring would sometimes pop through this tube. And so it pushes down. And you can see how it could pop through the tube, causing the spring and the tube to malfunction. And so, again, you can imagine what would happen if this happened. Well, the spring pushes the tube back down. And so if it's not on the bottom, it can't push it back down. And so this fencing here actually catches the spring and holds it back. And you might say, well, why don't they just add the fencing or make the fencing a part of the tube? And you'll see some of these sprinklers actually do have that. But this one does not. And I imagine the reason why is because if this little brittle plastic part breaks, you can replace just this small piece of fencing as opposed to the entire tube. And in fact, if you go to Lowe's to the sprinkler section, you will see many of these parts for sale by themselves without the rest of the sprinkler. So you can replace parts of the sprinkler or parts of your sprinkler system that break. And so many of these parts are designed to be replaceable. And if you look at this cap is actually not one piece. It is at least 3 pieces, but it's a little complicated to take it apart at this point. We need a screwdriver because, as you can see, there's a screw holding this piece together. For now, just pretend like this is one part. My question to you is, what is the point of that screw? Why is that screw there? And if you think about it, it should be kind of obvious, because when there's so much pressure coming out of this tube going into this needs to be held together. And so the screw, I imagine, gives it some structure and keeps these two pieces tight together to allow the water to stream through in a thin amount. And so the tube is where everything happens. The tube is inside our housing where the water comes through. And the tube is shooting up and down, depending on if the water pressure is pushing it up or the spring is pushing it back down. But as you can see, all the other parts sort of attach to the tube. The filter goes inside, the fencing inserts onto the bottom end of it, the cap goes on top. Before we put the cap on top, we need to put the spring through and then put the gasket on top. We insert the spring into the gasket, and then we can pull it down, make sure the filter doesn't fall out, and insert the cap back on, and it screws right on to the top of the tube. And then we can watch this system work again. You can imagine it working. And maybe you can even imagine it malfunctioning, it not working. So again, if this fencing broke off or the fencing was not there, what would the spring push off of to push the gasket up and the cap therefore back down? And finally, the tube goes back inside the housing and it fits nice and snugly. The rubber gasket fits nice and snugly right at the top of the housing. And then we can put the top of the housing back on and screw it back together. And then we can test to make sure it's still functioning correctly. Make sure we put it back together correctly by pushing it up and seeing if it pops back down. And voila. And so now, how to answer the questions in our structural analysis? Well, what you'll do is you'll take each part of our sprinkler and document what the function would obviously be, what the material is, and how each part interacts with the other parts. And so I can get you started. I can show you how to do a couple. So for example, the cap. Well, the cap, you may recall, was actually three parts sort of combined. We're going to call it one part. We're going to say it's made out of metal and plastic. And what is the function of the cap? Well, it is where water streams out of as it comes through the system. And how does it interact with other parts? Well, it connects to the top of the tube and is encased in the gasket when the sprinkler is off. And we can do one more together. How about the fencing? What is the function of the fencing? Well, it prevents spring malfunction. It holds the spring in place so it's able to push the tube back down. And the fencing is made out of plastic if you can't tell from the video or from the picture above. And how does it interact with the other parts? Well, it inserts onto the bottom of the tube and it acts as a base for the spring. And so hopefully you can fill out the rest of this table on your own. And then we can move on to the questions 2 through 6. And questions 2 through 6 are pretty straightforward. Just make sure you are answering in complete sentences. And so for example, was your hypothesis on the operation of the sprinkler that you completed in your functional analysis correct? In other words, in your previous lesson, when you hypothesized how this sprinkler system worked while it was still together, was that hypothesis correct? And your answers are, yes, it was correct, it behaves this way, or no, it was not correct, it behaves this way. And so would write something like, my hypothesis was not correct. The way the sprinkler actually works is, and then you'd fill in the blank. And again, you would just answer this question honestly and in complete sentences. Compare it back to your previous activity and your previous hypothesis. The next question asks, what is the purpose of the rubber gasket? Why do you think the designer chose to make it rubber and not some other material? Okay, the rubber gasket, as we already said, seals the cap when the spring is down. Rubber was most likely chosen because it acts as a good seal. Delete up here and bring that up. Question 4 asks, what is the purpose of the filter? Why do you think the designer made it plastic and not some other material? So basically, you just answer this the same way we answered the previous question. The purpose of the filter, and then be sure to answer both questions, fill in the blank. Question 5 says, sometimes when a sprinkler malfunction, the tube stays up even when the water is not on. And so something is causing the tube to just stay out, like so. And it just holds up. Even when the water turns off, it doesn't come back down. And it's saying, what do you think might cause the tube to malfunction and stay up when the water is not on? And so you would write, again in complete sentences, the tube stays up because, and fill in the blank, and you'd answer honestly. Why do you think the tube stays up? And hopefully the answer is pretty obvious. But if you get too confused, remember you can always come and ask me. And the last question is, what do you think the purpose of the metal screw is going through the cap? And so again, answer in complete sentences, answer to the best of your ability, and if you're confused, come see me about it and we can go over it together.